Hey everyone, Teacher Chang here, and today we're going to go ahead and take a look at radians. Now, radians are just alternate units of measurement used to measure angles in trigonometry and other higher level math courses. So we're going to take a look at what a radian is. Now, a radian is basically the angle that is made when the radius is wrapped around the circle. So I'm going to go ahead and highlight that really quickly right here because that's important. So the radian, again, is just the angle that is formed when you're wrapping a radius around the circle. So for example, right over here we have a radius. And if we take that radius and we just wrapped it around our circle, the angle that is formed, that is going to be 1 radian. So we can see that right over here, it forms an angle when we take that radius and we wrap it around. That's going to represent 1 radian. Now, a radian is about 57.2958 degrees if you want to go ahead and look at it in terms of degrees. And we can use the radians to calculate measurements. Now, the radian is often used with this symbol right over here. And this is going to be the theta symbol. Okay, so there's our radian. Now, this formula has the S and the R, and the S represents the arc length, and the R represents our radius. So if we have the arc length and the radius, we can go ahead and calculate the radian. Or we could go ahead, if we were given the radian and the radius, we could figure out, well, what the arc length might be. And if we were given the arc length and the radian, we could always figure out, well, what the radius might be. So let's take a look at these. Because a radian is based off of an actual part of a circle, we got to remember that this is a much more natural unit of angle measurement. And again, it's used for higher level mathematics such as trigonometry, algebra 2, pre-calculus, and calculus. So let's take a look at what we know about this radian. Now, because the radian is about 57 degrees, give or take a few, we know that it's going to take a little more than 3 radians to make half of a circle. And we could see that with this diagram right over here. So we got 3 radians over here. So we got a radian over here, we got 1 radian over here, and we got 1 radian over here. And then we just have a little bit more right over here. And that turns out to be the same value as pi, 3.14. So a half of a circle is going to be about 1 pi radian, or 180 degrees is equal to 1 pi radian. So if we actually take a look at a full circle, if 180 degrees is equivalent to 1 pi radian, well, that means 2 pi radians is going to equal to 360 degrees. And that's going to be useful information as we continue to work with radians later on. But our goal for today is to just go ahead and be able to convert a degree into radian, and then a radian back into degrees. So let's go ahead and start off with that. So we're going to do degrees to radians. And in order to convert a degree to a radian, what we're going to be using is we're going to use this formula right over here. It's basically our degree. Whatever degree that we're trying to convert, we're going to take that and multiply it by pi over 180. And that pi over 180, the degree symbol will end up canceling each other out. And you're going to notice that radians will not have a unit of measurement because pi is not a unit of measurement. It's a number. And since we cancel out our degrees, there will be no more units of measurement. And there will be some teachers that will say that it is the unitless measurement. But in any case, let's go ahead and start this off, and we're going to use this formula, and we're going to go ahead and convert some of these angle measurements from degrees to radians. So the first one that we have here is, what is the radian measure of an angle that is 30 degrees? So that's the one that we're going to do. And we're going to just take that 30 degree and place it right into this formula. So 30 degrees, and I'm going to put it over 1, and then I'm going to multiply it by pi over 180. and that's 180 degrees. So that's this part of that formula here. Now, when we multiply it, we can go ahead and cancel things out. And the first thing that I can cancel out are these degree signs. And now all I got to do is multiply. Now, I like to simplify before I multiply. So I know 180 can be divided by 30. So now that 30 and that 180 will cancel each other out. I'm just going to go ahead and change the color here. So the 30 and the 180. The 30 becomes a 1, and 180 divided by 30 becomes a 6. So now if we multiply straight across, 1 times pi is pi, and 1 times 6 is 6. So 30 degrees will have a radian measure of pi over 6. We could go ahead and do the same thing with this next two right over here. So pretty much the same thing. I'm going to take my degree measurement, and again in this case it's 60 degrees. We'll put it over 1, and then we're going to go ahead and multiply it by pi over 180. And again, the 180 and the 60, well, they have that degree sign that we could cancel out, so we could cancel out the degree sign, and then we could simplify 60 and 180. Now, 60 and 180, they both can be divided by 60, so this becomes a 1, and 180 divided by 60 is going to be 3, and now we got pi over 3. Okay. We could have done it differently. We know that 30 degrees is pi over 6, and 60 is twice that amount. So all we had to do was 2 times pi over 6, and we end up getting the same thing. So 2 pi over 6 can be reduced to pi over 3. If you want to do it that way, you can. Now, we also have 210 degrees. So same thing, I'm going to take 210 degrees, put it over 1. I'm going to go ahead and multiply that with the second portion of our formula, pi over 180 degrees. And again, we could cancel out the degree sign, and then we could simplify 210 and 180. They both can be divided by 30, so we could go ahead and say that the 210 becomes 7 and the 180 becomes 6, and we can now multiply that out. That turns out to be 7 pi in the numerator, and 1 times 6 is 6. So this is 7 pi over 6 radians. All right, so that's pretty much how you convert a degree to a radian. Now let's go the other way. Let's say we want to convert a radian back to a degree. So what we're going to do is pretty much the same thing. We're going to take the radian measurement that we have, and then we're going to, in order to convert it back to a degree, we're going to multiply it by 180 over pi this time. So we do want that degree sign, and what we're going to notice is that the only label that we're going to be left with is that degree sign, because the radians, they don't have a unit of measurement. So let's go ahead and try this out. I'm going to start off with that pi, that 4 pi over 3 in this first example. So 4 pi over 3, that's our radian measurement, and we're going to go ahead and multiply it with 180 over pi. So 180 degrees over pi. Now, again, I like to simplify some things here, and the first thing I can simplify is canceling out these pi's. Those pi's are gone. And I could also cross-simplify with that 3 and that 180. Now, they both can be divided by 3, so that 3 becomes a 1, and the 180 becomes 60. So now all I got to do is multiply straight across, and now I got 4 times 60, and 4 times 60 is 240, and then we have 1 in the denominator, so that's just going to be 240. And remember, that degree sign is still there. So now we have 240 degrees. So 4 pi over 3 is the same thing as 240 degrees. So let's try a couple more here. Let's try this next one. This time we got 5 pi over 4. And we're going to multiply 5 pi over 4 with 180 over pi. Okay, so we're just going to multiply these two together, and then again the pi's will cancel each other out. And then we're going to just see what else we can simplify. Now we could simplify the 4 and the 180. We could divide these by 4 here, and if we divide these by 4, the 4 will turn into a 1, and 180 divided by 4 is 45. So now all we got to do is multiply 5 times 45, and that's going to give us 225 degrees. All right, let's do one more, and then we're going to change it up a little bit. Here our radian is 2 pi over 3, and we're going to multiply that by 180 over pi. so we could cancel out the pi's. We could go ahead and simplify that 3 and that 180. So the 3 becomes a 1, the 180 becomes 60. And then all we got to do is multiply straight across. 2 times 60 is 120. We still have our degree sign. Now, a lot of the times when we're dealing with radians, if you haven't noticed, we will have that pi symbol in there. Now, you got to remember, pi is just a number, so there will be some occasions where you might have a radian where it doesn't have a pi in it, which is perfectly fine because a radian is the same length as, or it's the angle made from the length of our radius. So there will be some occasions where we might not have that pi. Let's go ahead and take a look at these problems. These are a little bit different. This time we're given the radius, we're given the arc length, and we want to go ahead and calculate the radians. Now for these particular problems, we're going to go back to that first formula that we saw earlier when we started looking at radians. And that was the radian, which is this theta symbol, is equal to our s, which is our arc length, over our r, which is our radius. So again, I'm going to write that out for you here. So we have our radian is equal to our arc length divided by the radius. Okay, so what we have here is we have the radius and the arc length, and now we can just go ahead and calculate the radian. So we know that the radian is our pi, that's what we're looking for, and that's going to equal to the arc length, which in this case is 18 pi, and we're going to divide that by our radius, and the radius is 3. Now, all we got to do is simplify that, and we have 18 pi divided by 3, and that's just going to turn out to be 6 pi. So again, radians, they don't have a unit of measurement, but some people will write down RAD for radians. Okay, now the degree, if we want to go ahead and write it in degrees, because it did ask us for both radians and degrees in this case, all we got to do is the same thing that we did before. So we're going to take our radian measurement, which is 6 pi, and we're going to go ahead and put a 1 underneath, so 6 pi over 1, and we're going to multiply it by 180 over pi. So we're going to go ahead and cancel out our pi's, and there's nothing else to simplify here, so we're just going to multiply straight across. So 6 times 180 is 1080 degrees. Okay. All right, let's try one more problem here, and pretty much the same thing. And in this case, you should be able to notice that, again, our arc length is only 32 centimeters. There's no pi here, and that's perfectly fine. So let's go ahead and take a look at this one over here. Again, we have our radian, which we use this theta symbol, and then we have our arc length, and the arc length in this case is 32. And we're going to divide that by the radius, which is 8. Okay, well, 32 divided by 8, well, that's just equal to 4. So the radian is 4 radians here. So a little bit more than our 180 degrees. So we know it's more than 180 degrees because we know that 180 degrees is 1 pi radian, which is about 3.14. All right, so let's take a look at, well, what is that in terms of degrees then? So degree, again, we're going to go ahead and take our radian, which was this 4 right over here. So we're going to take that 4, we'll put it over 1, and we're going to multiply that with, we're going to do 180 over pi, because we want that 180 degrees. We want to keep that degree sign. So now we're just going to go ahead and see what we could simplify here, and there's nothing that we could really simplify. So if we multiply straight across, 4 times 180 is 720 degrees, and then 1 times pi is over pi. Now you could leave it like this depending if your teacher wants it in pi form, so our answer could look like this. Or if you go ahead and use 3.14 for pi, or you type it into your calculator, you're going to get approximately 229.3 degrees. So if you actually use 3.14, it's going to be somewhere around there. Okay, so this is how you convert degrees to radians and radians to degrees. I hope this helped out. This is pretty much your stepping stone into your higher level math, because now we're working with radians. And again, it is a nice natural measurement that we like to use when we're working with trigonometry, algebra 2, and into pre-calc and calculus. All right, again, I hope this helped out. If you have any questions, go ahead and leave a comment. Don't forget to like the video and subscribe. All right, good luck, enjoy, and have fun.